All right, so here we are going to look at our graph of cosecant. I know I have this on the board behind me, but that won't show up on the recording. So I'm going to just draw it here. You can if you want to. If not, you don't have to. Again, I'm just doing this because the board doesn't show up on the recording that I'm doing. So I'm just going to put that there. So cosecant is the reciprocal of sine. So sine is the y value. We're going to go around and get all of our y values, but flip them, right? So starting at 0, what is your y value for this point? 0. You can't divide by 0. So when you flip that, do you remember what we put? Undefined. Good. Pi over 2. Now we're at the top of the unit circle. What's your y value? 1. If you flip 1, 1 over 1 is 1. Yeah, don't overthink it. All right, pi would be right here. Again, the y value is 0. Reciprocal of that is going to be undefined. 3 pi over 2, we're at the bottom of the circle. That's -1. If you flip -1, it's still -1. 1 over 1 is 1. It's just negative. And then back where you started, again, your y value is 0, so undefined. Now we're going to go backwards. At negative pi over 2, what are we going to get? -1. Good. And then at negative pi, we're over here, same as positive pi. So we're going to get what? Undefined. -3 pi over 2. That's going to put you at the top of the circle. So that would be 1 and then undefined. What's going to happen in the graph with all those undefined? If it's undefined, what does that mean happens in your graph? An asymptote. Good. Okay, so you're going to have a whole lot of asymptotes in here. So at 0 pi, we're going to have an asymptote. Which I know that's hard to see because it's on the axis, but just do your best. And then I'm not going to slide the paper up and down because I don't want to make you seasick. At pi over 2, it was 1 and then another asymptote. And then it was -1 and then another asymptote. So what this is going to look like, you can't connect those because you have those like prism bars in between them. The only choice that this point has is to go up. So you're going to end up with this U shape facing up, and then this one can only go down. It's going to be this U shape facing down. People call them parabolas. Technically, they're not, because a parabola is for a quadratic, and this is not a quadratic. It's a cosecant graph. But I mean, if you call them that, whatever. I just call them smiley faces and frowny faces. So that's one period of the function. And then that's going to continue forever in both directions. So you can keep going. Just show that you can continue the pattern. Just like fill it in for the rest of the space that we've got there. But like on your test, I would want to see like 2 smiley faces and 2 frowny faces. Now you can draw this on here if you want, you don't have to, but I think that this is really cool. And this is like the light bulb moment for me. I want to show you this. I'm going to put this in pink so that it's in another color. And again, if you don't want to draw this, you don't have to. But do you see what I'm drawing in there, how it goes in between? That pink graph is the graph of what? That's sine. Do you see how it's like we turned sine inside out? That's because sine and cosecant are reciprocal. Isn't that cool? It's like you turned the wave graph inside out. That's neat. All right, some things we noticed. I'm going to go through the same things that we did on all the other ones. First, domain and range. Domain is a little bit tough for these. It's everything except for your troublemakers. Do you remember how we always kicked out the troublemakers? Like leave them out? The problem is you have an infinite number of troublemakers because these asymptotes go forever in both directions. So here's how we write it. It's all x except for. So it's, if we're saying everything except for, it's all x not equal to. And here's how you write it because there's an infinite number of them. You start with the first one, and it's either the first positive one or 0, because there's an infinite number of them. But the rule is you take the first positive one or 0 if it's 0. This one starts at 0. Do you guys see that? Okay, so that's the first one plus however often they occur. plus pi. Do you see how there's pi units in between each one of them? Like they're spaced pi apart. So you're going to put plus pi n. N can be any number. So what you're saying is every pi, you get another one. So again, it's like there's an infinite number of. Range isn't as hard. You're just going to sweep downwards to upwards. It's going to be negative infinity up until -1 with a bracket. Union, because you have this missing space. Again, I drew in the sine graph there. Pretend that's not there. You have this missing space, and then you pick back up at +1, again with a bracket, to infinity. So again, it's like you turned the sine graph inside out. This graph is discontinuous. The only ones that are continuous are sine and cosine, those waves. All the rest of them are going to have asymptotes in them. This is an odd function, just like sine. So sine was odd, cosecant is odd, because they're going to go together like that. And again, that's going to come up later. That's why I'm bringing it up now. The period is still 2 pi. It's once around the unit circle. So every 2 pi starts over again. And the amplitude is none, which is really important. The only graphs that have an amplitude are sine and cosine. That word by definition is for a wave. So if you don't have a wave, it's none. You can't put 0 because 0 is technically an answer. Like that's technically a value. You have to say none for it. But that is kind of a gimme answer. Like it'll just be none for all of us. All right, so go ahead and flip over. We're going to do the exact same thing, but these ones are secant. So, and again, you don't have to draw this because it's on the board behind me. I'm just doing it so it shows up on the video. We go around the unit circle, we're going to flip all of the x values this time. It's going to look remarkably similar to what we just did. All right, what's your first x value? 1. If you flip that, it's 1. What's the next one? 0, so it's going to be undefined, and then -1, and then undefined, and then 1. When you go backwards, here's -pi/2. You go backwards, you would be down here. Your x value is 0, so undefined, and then the next one, going around the circle backwards now. So -1, good, undefined, 1. We're going to graph that, and again, it's going to look almost the exact same as what we just did on the other side, just starts in a different place. Remember how sine started at 0 and cosine started at 1? Like, it's kind of the only difference here as well. So we're going to start at 0, 1. That's our first point. And then an asymptote, and then -1, and then another asymptote. And again, just keep that pattern going. You can fill in, you know, the whole space. And then you get all these like smiley faces and frowny faces. I'm not going to draw it in on this one, but if I were to draw in this wave connecting those points, that would be the graph of cosine. It's like you turned cosine inside out. So domain, we're going to write it the same way. It's everything except for the troublemakers. The problem is you have an infinite number of them. So you take the first positive one, or 0 if it's 0, and that's where you start. So this one's not 0. Where's the first positive value we want to leave out? Pi/2 is where the first asymptote is. So the first positive one plus however often they happen, which again, they're happening every pi unit, so plus pi n. So every pi, you get another one. And then what is the range going to be? You want to sweep downwards to upwards. Negative infinity to -1, good. And then union 1 to infinity, perfect. And again, just make sure you use brackets. So exact same as on the other side. It's just shifted over pi over 2. That's all that happened. Exactly like with sine and cosine. It is discontinuous. Obviously. This one is an even function, just like cosine. Again, they go together. So like sine was odd, so cosecant was odd. Cosine was even, so secant is even. And again, that's just foreshadowing. We're going to use that later, so I'm bringing it up now. The period is still 2 pi. Once around the unit circle, that's one whole cycle. And again, the amplitude, you have to say none. You can't say 0 for that because 0 is technically an answer. The word amplitude is only for a wave. So since it's not a wave, it has to be none. Which if you remember that, it'll be an easy answer. So just try to remember that.